Okay, so I showed you what are we doing when we're finding a tangent? It's a line that is parallel to the curve at a certain point. So if we have a curve and we're finding the equation of a tangent. And so you saw we were synthesizing some skills we learnt in calculus, that is finding the slope, and then some skills we learnt in semester 1 where we're finding the equation of a line. We're bringing them together. So the two processes I showed you is we could use general form, or we could just use sort of some intuitive process to find the equation of a line. There is a third process. It's a formula. And I know we all like formulas, but I always like to do it last just so we sort of understand the context and the skills that we're doing. So this is the formula for a tangent, and this is the formula for a normal. Notice how the formula for the normal is just the negative reciprocal. That's the only difference between them. The value of A is the x coordinate of the POC, the point of contact. The value of f of A is the y coordinate of the POC, and f dash of A is the slope. X is going to remain as x because it's the variable. So we've got this function here. This is question 3, and we'll do the first one. Find the equation of the tangent at x is 1. Okay? So we know that to find a tangent, we need the point of contact and we need the slope. So when x is 1, let's find that. When x is 1, y is going to be 1 on 1 take 1 squared, which is 1 take 1, which is 0. Okay, so our point of contact is x is 1, y is 0. So two things we need for a tangent, point of contact and the slope. Okay, so if we want to find the slope, we need to find the slope function. So here's f of x. Before we can differentiate it, we need to express it all at the top of the fraction. Okay, so all I've done is that 1 on x has come to x to the power of minus 1. Index laws, that's why they're important. Okay, that's f of x, still the exact same function, and then we'll differentiate. We're going to have minus x to the minus 2, take 2x. Okay, so that's the slope function. And I'm just going to write that in a way that's sort of simplified. That's minus 1 on x squared, take away 2x. Okay, that's the derivative function. So let me draw some boxes around here so we're not getting confused. That's for finding the POC. Here's for finding the slope. So here's the slope function. We need to find the slope when x is 1. So we're finding f dash of 1. We're going to put the number 1 into this equation. We're going to have minus 1 on 1 squared. Take 2 times 1. That will be minus 1, take 2. The slope is minus 3. Alright? We have everything we need to put it into the formula. Okay? So let's go for the tangent. This is the formula we need to use. It's f dash of A times x take A plus f of A. So I'm going to write it out, okay, the equation of the tangent, and then beneath it, I'm going to put all the information in so you can see it. Alright, so the first thing we're going to put in is f dash of A, which is the slope. Now we saw the slope was minus 3. Alright, so we're going to put a minus 3 there. X stays as it is. X is our variable. A is the x coordinate of the point of contact. Our point of contact is x is 1, y is 0. So the x coordinate of the point of contact is 1. And then we have plus f of A. F of A is the y coordinate of the point of contact, which is 0. So plus 0, that's sort of obsolete. And then we can expand and simplify that. Minus 3x plus 3 is the equation of the tangent. Okay? Okay, so you can use a formula if you would like to. Right, I'm going to leave them aside. We're going to jump over to sort of question 3 and 4. So remember, for homework, I only set 1 and 2. I'm going to go through question 3A with you, and then I want you to have a go at 3B and question 4, sort of by yourself. So I've written 3A up here. It says find the equations of the horizontal tangents. Okay, so this is going to be a cubic, and it's going to look something like this. All right, it's a cubic function, x to the power 3. And horizontal tangents occur here, okay, when the tangent is a horizontal line. And here. Now what's special about those points is the slope is 0. It's not increasing, it's not decreasing, it's horizontal, it has no slope. So what we're going to do is we're going to find the derivative function, that's the slope function, and we want to find when the slope is 0. We're ready to differentiate here, that's all ready to go. So we'll go dy on dx is going to be, that 2 is hanging out, we've got 3x squared plus 3 times 2x, take 12. Okay, so that's the derivative function there. This will expand to 6x squared plus 6x, take 12. That's our derivative function. Now we want to find the equations of the horizontal tangents. Well, horizontal tangents occur when the slope is 0. This is the slope function, so we want to find when the slope is 0. Alright, now I'm looking at that and going, I need to make that equal to 0. That's a quadratic, okay, so we're going to factorise that and find the values of x that make that true. The first thing we can do is pull 6 out the front. Alright. We've got 6 times x squared plus x, take 2. And now when we're solving it, the 6 becomes obsolete because, remember, we can do anything to equations as long as we look to both sides. We could divide both sides by 6. Alright, so effectively we can ignore it when we're solving this problem. And so we're looking for two numbers that multiply together to give us -2, and when we add them together we get a positive 1. So it's going to be 2 and 1, and the question is just where does the negative go? And the negative goes on the 1, because you can see we'll have positive 2x, and negative x leaves you with 1 lot of x. Okay, so a bit of semester 1 quadratic factorization. Alright, so that means our solutions are x plus 2 times x take 1 equals 0. Okay, all we've done is go from that statement to that statement. These are the exact same function. Now let's apply the null factor law. Okay, so we have two solutions. X is -2 or x is 1. Alright? What these solutions mean, okay, what this processing means is if you take this number, -2, and you put it into our derivative function at any step, okay, you put -2 in here, it's going to equal 0. That's what it means. That's what the process that we've solved there. So we've found the x coordinates of these points. That's -2, and here x is positive 1. But we need the equations of the horizontal tangents. Now a horizontal tangent, any horizontal line, takes the form y equals k. Alright? Why? You can think of it like this. It's y equals mx plus c is the equation of the line. But a horizontal line has a slope of 0. So it's just y equals c. It's just going to be y equals some number. So all we need to do is find the y values at these points. And the y values of those coordinates is going to be the equation of the horizontal tangent. Okay, so here's the x values we've got. And we want to know what's the y values that correspond to those x values. And so we need to take these x values and put them back into the original function. Alright, so remember, f of x is the function. That tells us the y value for any value of x. F dash of x is the slope function. And so that's telling us the slope for any value of x. Alright? So we need to put it into the original function. We need to find when x is -2, what's the value of y? I'm going to put -2 into here to solve that. We'll crunch that in our calculator. -2, 3 plus 3 times -2 squared. Take 12 times -2 plus 1. And we need to know when x is 1. We have 2 plus 3 take 12 plus 1. 2 plus 3. So that one's -6. And this one.
I got 1
minus 6 for the top, this one as well.
Oh no, I got 21 for that one.
21, thank you. You approved that one. Okay, so we've found the y values. All right, all I'm saying is we've got these x values, we need the y values of these points. This is x is minus 2, this is x is positive 1. And when x is 1, y is minus 6. And when x is minus 2, y is positive 21. Okay, so then the equations of the horizontal tangents are going to be, therefore, horizontal tangent y equals 21 and y equals minus 6. Okay, I'm going to break that down a bit because it is a little bit tricky and you guys get to have an opportunity at doing one pretty similar. Okay, this is the function we're given. We're told find the horizontal tangents. Horizontal tangents occur when the slope is 0. So we find the slope function, derivative, we differentiate it, and we make it equal to 0. And we're saying what x values make that true. Okay? Here we've found the x values that make the derivative function equal to 0. Then we're going for a horizontal tangent, we're going to need the y values at those points. So we take those x values, we put them into the original function. That's what we're doing here. When x is minus 2, what's the value of y? When x is 1, what's the value of y? And a tangent, a horizontal tangent, has a slope of 0. So it's always going to be y equal to the y coordinate at that point. So that's why I've got y is 21 and y is minus 6. Okay, so I'm going to leave that up there. I'd like you to have a go at question 3b and question 4. Thank you.